Okay, so we are talking about agglomerative clustering. This is the first method that you use in hierarchical clustering. Alright, so in agglomerative clustering you have something known as single linkage, which we are going to be going through in this video. Next up is complete linkage, and we also have average linkage. Okay, so all of these are linked to each other, so all of these are very similar. Let's get started with the first part, that is going to be single linkage. So you would be given a matrix of this form, so we can just label it as say 1 2 3 4 5, and again 1 2 3 4 and 5. So in agglomerative clustering, what we are going to do, which is going to be common to all of these three kinds of linkages, is we are going to spot what is the minimum distance in this entire matrix. So we can see we have got 2 3 4, so 2 is the least, so that is going to be 2 and 1, right? That is giving us this 2 here, right? So what we are going to do is we are going to merge these two together. Okay, so we are going to merge these together. So this is going to give us something like this. This is going to be 1 2 3 4 5 1 2 3 4 5. I hope you all understood what I was trying to say, is that we have got the minimum value over here, which corresponds to which row? The second row and the first column. So we are going to merge the second row and the first column, so we are going to be having a matrix of this kind, right? So we are merging these two, so this is going to give you a 0. All the diagonal elements are going to be 0, because the node's cost to itself is going to be 0. Okay, now we have to find out the values, these values and these two values. Rest, these are going to be same, so I'm just going to write down. So the value of fifth row, fourth column is 4 over here. Okay, let's go ahead and find out the values. And 4 3 is also going to be the same, so that is going to be a 7 over here, and 5 and 3 is also going to be the same, so it is this value. So we have to find these three values, 3 4 and 5, with respect to 1 2. So now what I'm going to do for finding the value that will come here for 3, right? You have 1 2 as one unit and you have 3, so I'm going to find the distance of 1 3 and 2 3. Let's see what the values are. So 1 3 is going to be this value, that is 6, and your 2 3 or your 3 2 is 3, right? So when we are talking about your single linkage, you find the minimum of these two values, and it, of course in this case, is going to be 3. So here the value that comes out is going to be 3. We move ahead. The same thing we do for 4. So we find the distance of 1 4 and your 2 4. 1 4 is going to be 10. Let me just change the ink, and it's going to be 10, and your 2 4 is going to be 9. So out of these, the minimum is your 9. So the value here comes out to be 9, right? Now we move on to the next one. We do the same thing for the fifth one as well. So this is going to be the distance of 1 5 and 2 5. So it's going to be, here you have 9 8. Again, this is going to be 8, right? So we have gotten this. And when you talk about agglomerative clustering, right, they're going to give you this entire thing, and you have to construct something known as the dendrogram. So dendrogram is going to be a graphical representation of the clusters. So in this case, I made a cluster of 1 and 2 together at the level of 2, right, at the value of 2. So if I'm keeping it here like this, and we could have easily just called it 1 okay, that's just fine. So 1 2 3 4 and 5. So I made a cluster of 1 and 2 at this value, at the value 2. So this is going to be my dendrogram currently, right? It's very important for you to have this labeled over here. Your y-axis has to be labeled, or else the paper corrector won't be able to understand at what point you have made this particular bar, right? And it also counts as copy case if you don't have this thing done. Usually people forget these ticks. So yes, that is another thing. Let's continue. So here we have gotten 3 to be the minimum costing, and that is again for third row and 1,2 column, right? So we are going to be merging these two. So we'll have 1,2,3, 1,2,3, 4, 5, 4, 5. So now that our matrix is formed, again I'm going to mark the diagonal values to be 0. So fifth row and fourth column, the value is going to remain unaffected, so that is going to be 4 here. We have to find these two values, so let's get on with it. So we have to find the values which is going to be replaced in this cell, right? So for fourth we have to do, so it is going to be the minimum of the distance of 1,4, distance of 2,4, and the distance of 3,4. So we are going to take these values from the original only. So that is going to be 1,4 is 10, 2,4 is 9, and 3,4 is 7. So the minimum over here is 7. So the value that you get over here is going to be 7. Next one, we try the same thing for fifth one. So that is going to be 5. Again, what we are going to do is we are going to update the dendrogram over here. So you see, we decided to merge these two at the row number 3, right? The row number 3, we decided to merge this cluster 1,2 with 3. So at the level 3, we decided to merge 1,2 cluster with this cluster 3. So it is happening at level 3. So this is what the graph or the dendrogram would look like. So now we can see that for row number 5 and column number 4, we have got the least value over here, the least cost. So we are going to be merging the row 5 and column 4. So we'll have the groups 1, 2, 3, 4, 5, right? So that's going to be 1, 2, 3, 4, 5. So the diagonal elements are going to be 0. We have to find this value now. So what we have to do is we have to find what is the least value for distance of 1, 4, 2, 4, 3, 4, and 1, 5, 2, 5, and 3, 5. So this has to be the minimum distance. So it is going to be 1, 4 is 10, 2, 4 is 9, 7, 8, 9. 1, 5 is 9, 2, 5 is 8, and 3, 5 is 5. So out of all of these, the least is 5. So we have gotten the value, the final value to be 5. We have to come over here, we have to update the dendrogram. So you have to make sure that your dendrogram, you make your dendrogram for like every step that you are taking. Here I have made a common dendrogram, but you make sure that for every step that you're doing, you make individual dendrograms, and then you combine all of your clusters together and make a separate final dendrogram. So here we combined your 4 and 5 for the value of 4. So I'll just extend it a bit. Here is 4. So this 4, 5, I extended it for the value of 4. And then what we are going to do is we are going to connect these two clusters like so. So that is it for this video, guys. I know that there is a slight problem with the audio. I'm trying to fix it, and I'll make sure that in the upcoming videos no such problem happens. But keeping that aside, single linkage plays a very important role in your entire agglomerative questions asked, because this is one of the most frequently asked type of linkage to solve. And if this gets asked individually, it would be for 5 marks, and if all the 3 types are asked, that would be for 10 marks along with a little bit of theory. So make sure that you're following all of these 3 videos just so that you know how they are different from each other and how they get linked to each other. Also make sure that you are understanding and making the dendrogram correctly, because during Vivas there is a chance that they would ask you questions related to dendrogram as well. That is it. Bye.